In the realm of machine learning and AI, creating custom components is a crucial skill. Custom components allow data scientists and developers to tailor their models and pipelines to specific needs, enhancing performance and flexibility. This presentation will delve into the various aspects of creating custom components, particularly in the context of preparing a model for deployment, as outlined in the DP100 course. Custom components are user-defined elements that can be integrated into machine learning pipelines. They can range from data preprocessing steps to complex model training routines. The primary advantage of custom components is their ability to address unique requirements that standard components may not fulfill. By creating custom components, you can optimize your workflow and ensure that your model meets specific criteria and constraints. Custom components are essential for several reasons. They provide flexibility, allowing you to implement bespoke solutions tailored to your data and objectives. They also enhance reusability, as custom components can be shared across different projects and teams. Moreover, they improve maintainability by encapsulating complex logic within well-defined modules, making it easier to update and debug your code. Creating custom components involves several key elements. First, you need to define the component's functionality and interface. This includes specifying input and output parameters, as well as any configuration options. Next, you need to implement the component's logic, ensuring it performs the desired operations efficiently. Finally, you need to test the component thoroughly to ensure it works correctly within your pipeline. The interface of a custom component is crucial, as it dictates how the component interacts with other elements in the pipeline. A well-defined interface includes clear input and output specifications, as well as any necessary configuration parameters. This ensures that the component can be easily integrated and reused in different contexts. Proper documentation of the interface is also essential for maintainability and collaboration. The implementation of a custom component's logic is where the actual functionality is coded. This involves writing the necessary algorithms and operations that the component will perform. It's important to focus on efficiency and scalability, ensuring that the component can handle large datasets and complex computations. Additionally, adhering to coding best practices and standards will make the component more robust and easier to maintain. Testing is a critical step in the development of custom components. It ensures that the component performs as expected and integrates seamlessly into the pipeline. Unit tests should be written to validate individual functions and methods within the component. Integration tests are also necessary to verify that the component works correctly when combined with other elements in the pipeline. Thorough testing helps identify and fix bugs early, improving the overall reliability of the component. Once a custom component is developed and tested, it needs to be integrated into the machine learning pipeline. This involves connecting the component to other elements, ensuring that data flows correctly through the pipeline. Proper integration requires a good understanding of the pipeline's architecture and data dependencies. It's also important to monitor the component's performance within the pipeline, making adjustments as necessary to optimize efficiency and accuracy. To illustrate the process of creating custom components, let's consider a case study involving custom data preprocessing. Suppose we have a dataset with unique formatting and missing values. A custom preprocessing component can be developed to handle these specific issues. This component might include steps for data cleaning, normalization, and feature extraction, tailored to the dataset's characteristics. By integrating this custom component into the pipeline, we can ensure that the data is prepared optimally for model training. Another example of custom components is in model training. Suppose we need to implement a specialized training algorithm that isn't available in standard libraries. A custom model training component can be developed to incorporate this algorithm. This component would include the necessary logic for training the model, such as gradient descent optimization or custom loss functions. By creating and integrating this custom component, we can leverage advanced techniques to improve model performance. When creating custom components, it's important to follow best practices to ensure quality and maintainability. This includes writing clear and concise code, adhering to coding standards, and documenting the component thoroughly. Additionally, version control should be used to track changes and collaborate with team members. Regular code reviews and refactoring can also help maintain the quality of the component over time. By following these best practices, you can create robust and reliable custom components that enhance your machine learning pipelines. Creating custom components can present several challenges, such as handling complex logic, ensuring compatibility with other pipeline elements, and maintaining performance. To address these challenges, it's important to break down the component's functionality into manageable parts, use modular design principles, and leverage existing libraries and frameworks where possible. Additionally, thorough testing and performance monitoring can help identify and resolve issues early. By anticipating and addressing these challenges, you can create effective custom components that meet your specific needs. The field of custom components is continually evolving, with new tools and techniques emerging to simplify and enhance the development process. Future trends may include increased automation in component creation, more advanced debugging and testing tools, and greater integration with cloud-based platforms. Staying informed about these trends and adopting new technologies can help you stay ahead in the field and create even more powerful and efficient custom components. Creating custom components is a vital skill for data scientists and developers, enabling them to tailor their machine learning pipelines to specific needs. By understanding the key elements of custom components, following best practices, and staying informed about future trends, you can enhance your workflow and improve model performance. The next steps involve applying these concepts to your projects, experimenting with different custom components, and continuously refining your skills. With practice and dedication, you can master the art of creating custom components and take your machine learning models to the next level.